evaluating nutrition information. We are bombarded with nutrition information almost every day. The evening news, the morning papers, the internet continuously offers us all kinds of tantalizing just tidbits of nutrition advice. Food and nutrition information that used to take professionals years to get out to the public now travels with lightning speed, reaching millions of people within hours or days. And much of this information is reliable, but some can be misleading. And in order to choose a healthy diet, we need to be able to sort out the useful material in this flood of information. And that's what we're going to talk about in this module. And this will also be the homework assignment with this week will be evaluating nutrition research. So what is the science behind nutrition? So the science of nutrition is constantly evolving. It uses the scientific method. The scientific method is the systematic, unbiased approach that allows any science to acquire new knowledge and to correct and to update previous knowledge. In nutrition, the scientific method is used to develop nutrient recommendations, to understand the functions of nutrients, and to learn about the role of nutrition in promoting health and preventing disease. The science of nutrition and the scientific method involves understanding some terms. It involves making an observation. An observation is looking at something and asking questions about it. It involves proposing a hypothesis. A hypothesis proposes an explanation for an observation or a scientific problem that can be tested through experimentation. It involves designing and conducting experiments to test a hypothesis and analyzing those results and publishing it and presenting it so other scientists can look at it, other peers can review it to see if what has been tested or proposed measures up to what other scientists already know or are questioning. And repeat and expand the experiments so the scientific evidence becomes stronger as more and more experiments find the same results, and then develop theories based on the results from many experiments. So if the hypothesis is supported, develop a theory. If the hypothesis is not supported, a new hypothesis can be formulated. Again, a hypothesis. So that's the proposed explanation for an observation or a scientific problem that can be tested through experimentation. And a theory is a formal explanation of an observed phenomenon made after a hypothesis has been tested and supported through extensive experimentation. So let's look at the scientific method here. So the scientific method, again, is a process used to ask and answer scientific questions through observation and experimentation. So the first step of the scientific method is to make an observation and ask questions about an observation. So in this example, they observed more people get colon cancer in the United States than in Japan. So that someone observed that. So do we decide? The next step is to propose an explanation for this observation. This proposed explanation is called a hypothesis. So we're going to hypothesize that the lower incidence of colon cancer in Japan than in the United States is due to the differences in their diet. So that's our hypothesis. So once the hypothesis has been proposed, experiments can be designed to test it, to generate theories, to test the hypotheses, to see if we produce consistent, quantifiable results, and to see if we can interpret those accurately. So the experiment here is to compare the incidence of colon cancer of Japanese people who move to the United States and consume a typical U.S. diet with Caucasian Americans who eat the same diet. And what was the result? The result was that the Japanese people who eat the U.S. diet have the same higher incidence of colon cancer as Caucasian Americans. So step 4 in the scientific method is, if the results from the repeated experiments support the hypothesis, a scientific theory can be developed. So a single experiment, though, is not enough to develop a theory. Rather, repeated experiments showing the same conclusion are needed to develop a sound theory. So it's the beginning, but lots more experiments need to happen. So step 5 is, if the experimental results do not support the hypothesis, so say we compared the Japanese people who moved to the United States that consume the typical U.S. diet with Caucasian American diets who eat the same diet, and there still wasn't an incidence of higher colon cancer. So maybe diet is not the reason, maybe it's genetics. But in this sample, the Japanese people who did eat the U.S. diet had the same higher incidence of colon cancer of Caucasian Americans. So our theory is that the U.S. diet is what contributes to the development of colon cancer. And that is a theory, and as new information becomes available, even a theory can be accepted by the scientific community for years until it's proven wrong. So the process of the scientific experiment, like all other sciences, the science of nutrition is constantly evolving, and new discoveries provide clues to the right combination of nutrients needed for optimal health. New nutrition principles and recommendations are developed, and some established beliefs and concepts give way to new information. So how do scientists study nutrition? It's very well studied. They do use different types of experiments. Epidemiological studies make observations about relationships between diet and health. Epidemiological studies of populations around the world explore the impact of nutrition on health. If you were to measure, say, saturated fat intake and the incidence of heart attacks in different populations, you might graph that to determine what diets with a high percentage of calories from saturated fat are associated with an increased incidence of heart attacks. Though it doesn't determine the cause and effect relationships, it just identifies patterns. Experimental studies are clinical trials that explore the health effects of altering people's diets. Animal studies explore the health effects of altering diets in animals. And biochemistry and molecular biology, laboratory-based techniques that are used to study nutrient functions in the body. So animal studies, because they're costly and time-consuming to do studies on humans, and sometimes impossible for ethical reasons, many studies are done using animals. Guinea pigs are good models for studying heart disease, but even the best animal models are not exactly the same as human. And so care must be taken when we extrapolate animal results to humans. Clinical trials, the observations and hypotheses that arise from epidemiological studies can be tested using clinical trials. So that might be the health effects of altering one's diet one person group of experimented on is eats a diet low in saturated fat and one high in saturated fat, and what is the effect on blood cholesterol levels? That might be a study. The biochemistry and molecular biology techniques used in a study can evaluate cholesterol and genetics and that type of study. So here, here's a graph of the epidemiological study that I was talking about, 10-year heart rate attack incidence in people per 10,000 people as compared to the percentage of calories from saturated fat. And as people, the red dot show as populations consume higher amounts of saturated fat, their risk for a heart attack or their incidence of heart attack increases. So the most important thing is that the data is collected, is reliable, it can be quantified or measurable. Examples of measurable information might be body weight, blood pressure, blood cholesterol. Things that can't be measured are testimonies or people's opinions. So what kind of questions to ask about nutrition data? So the first thing I always ask, is it too good to be true? So that weight loss pill that guarantees weight loss, we know that's too good to be true. Who's providing the information? How do they benefit from it? Are they selling a product? Is the benefit for what is the who is benefiting from this? Is it a famous person promoting a supplement? They're gaining economics from it. Who do they have something? Who performed the study? Were there even studies on it? Do they link to those studies? Are they peer-reviewed studies? And are there other studies to support this information? So be very critical. The point I'm getting at with all of this is being very critical of when someone provides nutrition information, does it seem too good to be true, and what studies are behind this? So this week, when you're evaluating nutrition information, look back at the scientific information. Not all nutrition information we encounter is accurate, and the first step is deciding whether a nutritional claim is valid is to ask whether it makes sense. If it sounds too good to be true, it probably is. It is important to determine whether the information came from a reliable source, a registered dietitian, whether it is trying to sell a product, and whether it has been confirmed by multiple studies.